That is extremely powerful, and I don't know why more people aren't doing that. We're in the midst of an AI revolution, and if you're watching this, you probably know that already. What you might not realize is that the way these new AI models read data has pretty big implications on the optimal way that we should store data. It seems pretty likely that one of the biggest applications of these new large language models is to facilitate tasks that rely on some specific body of information that wasn't necessarily in the data that the model was trained on. One example might be a company's set of proprietary internal documents. For example, maybe a brand new employee wants more information about how to perform their job, and your company maintains a large knowledge base about how to perform that role. If you just store this knowledge base as text and maybe some videos, yeah, the employee might be able to search it in the traditional way where they type in some keywords into a prompt and then get some results based on exact matches of their keywords. That might get them close to what they're looking for, but there's bound to be a gap between the search results and the exact answers that they were actually looking for. There are two approaches that can close the gap and get that person closer to the information that they were looking for straight from their original prompt. One is called semantic search, and that means searching based on the underlying meaning of the keywords rather than the exact sequence of characters that they're represented by. Another approach is feeding the knowledge base into a large language model like ChatGPT. Both of these approaches rely on what's called vectors, which are computed based on the text. And in this context, you can just think of vectors as just big arrays of numbers that capture the semantic meaning of a given word or sentence. Words or sentences that have similar semantic meanings are generally represented by vectors that are similar to each other. For example, if we had decided to represent words with two-dimensional vectors, which isn't realistic because large language models typically use hundreds or even thousands of dimensions to represent vectors, but those are pretty hard for us to visualize. But if we have only two dimensions, it becomes pretty easy to visualize them on a Cartesian plane. So given a two-dimensional Cartesian plane, two words that appear close in proximity generally share a similar semantic meaning. There are some details that we're skirting over, but this is how large language models like GPT make sense of words and their relationships to one another. Okay, right, so back to vector databases. If we're doing things like semantic search and using our knowledge base as context for our prompts to language models, it makes sense to store pre-computed vectors for the knowledge base, so the parts of the knowledge base most relevant to our prompts can be found quickly. And then, because those vectors are used to hone in on the relevant parts of the knowledge base for a given prompt, the pieces of the knowledge base used to generate the response prompts can be surfaced along with those responses, so if the user wants to, they can dive into the sources for that response. I'm personally really excited about the field of natural language processing and the recent breakthroughs in the performance of large language models, which I think is really going to start to put vector databases in the spotlight. So I'm excited to say that this video is sponsored by Nuclia, who make both a free and open source vector database called NucliaDB and an understanding platform that integrates with it. This platform allows you to perform searches and get generative answers based on the data in your NucliaDB. Think of it this way: you put all of the source material you'd like to make queryable in what's called a knowledge box. And that can include audio and video, which actually will be transcribed to text automatically for you, which is amazing. Once your source material is in your knowledge box, there are a ton of possibilities. One of which is to literally have a ChatGPT-like conversation where responses to your prompts are generated based on the content of the resources you put in the knowledge box. Having a knowledge box of information and having the ability to get AI-generated answers based on the entire body of information is actually really nice, because pre-trained large language models, as great as they are, always have a limit on the number of tokens or words that we can have in the prompts that we feed them. So you can't always just pack all the relevant information into the prompt. Anyway, there are some other really nice features of Nuclia that we haven't even talked about yet. So let's walk through how to get started with Nuclia and some of the cool things that you can do. Again, NucliaDB is open source, so you can actually run it locally if you want to, or you can use the hosted cloud version, which we're also going to show in this video. So this is the Nuclia web interface. First thing I'm going to do is create a knowledge box. So I'll go to knowledge boxes and do add knowledge box. We'll call it CTTM. You can add a description if you want. You'll get to choose from a few options here, mainly around what models you want to use for embeddings and answer generation. For the case of answer generation, multilingual means a model that's hosted by Nuclia themselves, or you can choose to use ChatGPT for answer generation. So for our demo, I'm going to choose ChatGPT. Go ahead and save, and our knowledge box is created. So now we can go click on the knowledge box, we have a bunch of options here. We can click on resources list, and we can just start putting stuff into this knowledge box. So I'm going to click on upload, do upload files, and I have some files that I've collected for this demo. I've got 2 PDFs of actual video scripts that I've done. I'm going to add an astronomy podcast that I have an MP3 file for. So this is pure audio. There's no text in this file. And then a hypothetical company new hire guide for new hires to read when they first join. This is something I completely made up. So I'm going to add all those files. I can select labels if I want to, which I'll get to later. But for now, I'll just do add. Okay, the files are uploading and we get some check marks when they're done. So we'll just go ahead and wait for this podcast to finish uploading. Now we're good. And when you first upload things, they'll be in a pending state where Nuclia is actually transcribing the audio or video and generating embeddings based on the text, whether that text was derived from audio or video, or it was extracted from a PDF, or the original document was text. It's generating embeddings for those. I can see what's in pending by clicking on this pending icon here, and we can see our resource processing queue here. In the meantime, I mentioned you can actually add links to things in your knowledge box, including HTML pages or YouTube videos. So let's look at this NASA article about some double quasars that were found by the Hubble Space Telescope. Let's try adding that to our knowledge box. So we can do add links, paste in that link there, and boom, we've added that to our knowledge box. It gets processed in the same way that any files that we upload will. And then also, let's take a YouTube video. So there's this YouTube channel called DistroTube, which is a Linux-focused YouTube channel. That's great if you're into Linux. Check him out if you're into Linux. So we'll grab one of his videos, add a link to it into the knowledge box, and add. And we can see that gets added, hopefully, to our pending files. Yeah, so now these are pending as well, in addition to the files that we uploaded. So let's wait for this to finish. And just like that, our resources are finished processing. So we can see we have 6 resources here. We have a YouTube video, a podcast episode in audio format. Let me rename this. This is a Quasar article. Quasar article. Yeah, so we have our YouTube video, our Quasar article, our podcast in audio format, and my 2 PDF scripts for YouTube videos, and then our company new hire guide. And we can click into any of these and view the text. So for in the case of the audio file, we see we have a full transcript here of the podcast episode, which is awesome. And same thing for the YouTube video, full transcript here. And then the PDFs obviously have been converted to text as well. Now that we have these resources in our knowledge box, what can we do with them? The first feature I want to show is named entity recognition. And named entity recognition is a field of natural language processing that involves looking at a body of text and kind of extracting things from that text and putting them into some kind of an ontology or classifying them in some way. And an example of this would be locations. So I can take a look at the locations that were mentioned in my knowledge box. And you can see we have Hawaii, Maryland. I don't know which exact resources these are from. And then we can go to something like nationalities. We have Roman, Swedish, Ukrainian. We also have Rust. Apparently Rust is a nationality. It's not entirely wrong given the literal use of the word. So Rust Nation, nice. I like that a lot. Named entity recognition is just one of the things that you get when you upload resources to your knowledge box. Another thing is classification. So there's a concept of label sets. A label set is a collection of labels, and you can apply labels to your resources, either at the document or resource level or a paragraph level. So let's add a new label set. We'll call this astronomy. And we'll apply this label set to resources as a whole. Each resource in your knowledge box has one or more paragraphs. So it depends on how granular you want to get with your labeling. And each label set can apply to either resources or paragraphs, not both. And then we'll add individual labels inside the label set. So we'll do deep space and like solar system, stuff related to astronomy. Click save. Our label set's been created. Now we can go back to our resources list and categorize or tag our resources with that label. So we can click on the astronomy podcast, go to classification, resource, and then select the labels that you want to apply. So I think there's some stuff about deep space here. They talk about dark energy and stuff. So I'll apply that label to the entire resource. Say I want another label set that I apply on a paragraph level. I'll create another label set. We'll call it Rust, and it's applied to paragraphs. And we'll only make one label in there. We'll call it smart pointers. Save. Now we can go back into our resource list and click on the Rust alien data types resource, which is a script for my YouTube video of the same name. And we can go to classification, select some labels that we want to apply, smart pointers, and we can, on a paragraph basis, we can apply this label. So in reality, this label probably applies to pretty much every paragraph in this video, but I just wanted to show what paragraph labeling looks like. So we'll save that. There's 2 things labels allow you to do. They allow you to filter if you want. So you can filter by a label in your resource list, and you can use them to automatically classify new resources that you upload. If you want Nuclia to automatically apply labels to new resources that you upload, like deep space or Rust smart pointers, you would tag some existing resources with those labels like we just did, and then you can do what's called a training. So if we go to trainings, and we can do either automatic resource label training or automatic paragraph label training, depending on which label you want to train for. And I can select astronomy, and it will train for every label in that label set. It will see what sorts of things, what semantic meaning the things that that label has been applied to have, and anything new that's being uploaded to the knowledge box, if it has a similar semantic meaning to the things that already have that label applied, it will automatically apply that label to that resource. That's really cool. So again, you can do that on a resource level or a paragraph level. Next thing is search. And Nuclia actually allows you to embed the search box that you see here into your website, and it gives you the markup for doing that. And the results for the search box will be populated based on your knowledge box. So that's really cool. And to configure all that, you go into the widgets page. So we can see our search box here. We can see the markup for the search box that we can copy and paste to our website. And that markup will be adjusted based on the flags that we set here. So you can see it changing as we check and uncheck some options here. This search box is actually pretty powerful. It does do full text search as you would expect from any search box. So if you search Linux, it's going to find some exact matches for Linux. And again, this is a video. We're searching for full text inside a video transcript. So that's really cool. But even cooler is it'll do semantic search. So it'll search for sentences and terms with meanings similar to the words that I put in the box, but that aren't necessarily exact matches to the words that I use. So I can do, are paintings fun to look at? And the term paintings, I don't think it comes up anywhere in any of the resources that we've uploaded. So let's try that. Let's see what it comes up with. Yeah, it doesn't look like there's any exact matches. Oh, there's the word fun comes up, but the word paintings does not. So let's look at this particular search result. There's 0 full text exact matches in this result here, but it does contain the words abstract art and accent color. So those are semantically similar to paintings, presumably. Here's another one. They're a little more vibrant, and it's especially noticeable. So the word vibrant and then also color themes. Again, semantic similarity to paintings. So that's an example of semantic search. Now to the really powerful aspect of the search bar. So we can do generative answering similar to something like ChatGPT. We just check on answer generation and we can type in a question. So what is dark energy? I think the podcast talks about this. Dark energy is a mysterious force or energy that is causing the expansion of the universe to accelerate. Its nature and origin are not still fully understood by astronomers and scientists. That's coming from the resources in our knowledge box. And then you get based on these resources. So you can drill down into where that answer actually came from. And sure enough, you can see it came primarily from the astronomy podcast. That's really cool. So take a step back for a second. We uploaded an audio file. It automatically transcribed that audio file to text. And now we're getting generative answers based on that text from a question that was asked in natural language. That's really cool. I do have a very important question to ask it. What do? I break the build. Not relevant to me. I'm asking for a friend, by the way. If you break the build, you're expected to bring the team 12 donuts within 1 working day of the build break. And yeah, that's coming from this kind of new hire guide that I contrived for this video from the second paragraph. So it answers in plain language. Donuts are always a good idea when you do something bad. How do we know that dark energy exists? Okay, so similar to the last one, we know it exists because of the accelerating expansion of the universe. Nice. Taking a step back a bit, I can think of 2 main use cases for this, one of which is selfish and one of which is maybe not quite as selfish. So the selfish one is, as an individual user, I can dump all the resources that I'm interested in into a knowledge box and basically have a ChatGPT-like conversation with it. I can dump articles and documents, anything I might be interested in, into my knowledge box and ask questions until I get what I'm looking for. That is extremely powerful, and I don't know why more people aren't doing that. The second use case is obviously to embed the search bar onto a customer-facing website of some kind. So you have a knowledge base to answer customer questions, and all they have to do is type the answer into the search bar, and they get an answer in plain language. And if they want to, if you enable it, they can drill down into the exact resources that were used to generate that answer. I personally think we're going to see vector databases being used extensively for both of those purposes. So this is a cloud/hosted version of Nuclia. What if we want to deploy Nuclia locally? Again, NucliaDB itself is open source, so we can do that. And we can write a Python program to compute vectors from documents and upload those documents along with those vectors to our NucliaDB instance. And then we can perform some semantic search against the vectors in that database. Let's see what that looks like. There are some instructions on how to run NucliaDB locally here. Basically, we just run the Docker container. So we'll go ahead and copy and paste that into our terminal. Go ahead and wait for that to download. And it's done just like that. So So we have it running on port 8080. Let's take a look at this program. You do need to do a pip install of two packages. One is nucleadb_SDK. Another is sentence_transformers. And that's what we're going to be using to generate the embeddings for sentences. And this program is pretty simple because by default, the nucleadb SDK assumes that you're running to a locally running nucleadb instance. The first thing we're going to do is grab an encoder to create embeddings for our sentences. So it's going to capture all the semantic meaning of our sentences here into one vector, a vector per sentence. And we have 4 simulated documents, which are actually just sentences, but obviously these could potentially be multiple sentence documents. For simplicity's sake, they're just one sentence each. So we have 2 statements that are kind of related to artificial intelligence, a statement about Rust, and a random statement saying the sky is blue. We'll get to why we have those in a minute when we do semantic search. So to create a knowledge box, if you don't have one already in your database, just do create knowledge box, and that's in the nucleadb SDK. You pass in the name to the knowledge box. And then when you're uploading documents to your knowledge box, each document can have one or more vectors associated with it. And a vector set is a common name or common type of vector that should exist across all or might exist across all documents in your database. So in this case, we're creating a vector set with the name of the encoder that we have, and then we're going through all the documents, which is just 4, and we're computing the vector of that sentence or document in our case. We're calling .upload on the knowledge box, and each resource needs to be associated a key. So we're generating a key, and then we're specifying the text associated with that resource. We can specify any labels that we'd like to apply immediately, and then the vectors that we want to associate with that document. You can store different types of vectors for the same document. In our case, we're just storing this one, which we're going to use for semantic search. So let's go ahead and try running this. So that should have uploaded all 3 of those resources to our local running nucleadb instance. Now let's look at what we need to do a semantic search against the vectors that we put in our database, or the documents that we put in our database. This is a different file. So first we have to determine what vector set that we want to use to search. So again, we put the same name as the vector set that we specified in the other file, the file that uploaded the documents. And we specify a search string. So our search string will be brains have axons and dendrites. Then we're going to compute the vectors for brains have axons and dendrites by using the same encoder that we use to encode all the documents or create vectors for all the documents. And then we call my_knowledgebox.search. And by the way, this is using the same Python session as the previous file. So my KBE still exists, the one that we set up in the previous file. So we're going to call .search. We specify the vector that we want to use to search and the vector set name that we want to use to search, because each document, again, might have multiple vectors associated with it, and each vector is associated with a given vector set. We can use a filter to specify a label that we want to filter our results on. So we'll specify one here, and then we just print out the text and the labels and the score associated with all of our results. So let's go ahead and run this. And we can see we kind of get what we expect. Our search string was brains have axons and dendrites, and our result with the highest score is right here. Neural networks are getting really smart in recent days. And that is a score of 0.299, which is the highest of all these. And then the second highest is in 2023. It appears that we are on the cusp of artificial general intelligence. So again, both of these are related to intelligence. The intersection of words between these 2 search results and the search string is nothing. There's no common words between those sentences. There's no common words between the search string and either of the results. The results have some words in common, but if you intersect the text of each of those documents with the search string, the intersection of words should be nothing. Then our third result is Rust is a really nice programming language. And presumably, maybe there's some semantic similarity here with brains have axons and dendrites. Maybe programming is semantically similar to brains, because you can see it got a much higher score than the sky is blue. It got 0.09. The sky is blue got the lowest score, which is 0.027, which is kind of intuitively makes sense because of the 4 documents that we have in the database, it is definitely the one that has the least semantic similarity with our search string. So again, we're running a free and open source instance of nucleadb locally, and we're putting some documents in there, computing the vectors and associating those with the documents. And then we're doing semantic search based on the vectors that we've computed for those documents. And this is all happening locally. You can also integrate with what's called Nuclia's understanding API, which is what the hosted version uses to compute or transcribe audio and video, and do some of the other more advanced features that you can only do on the hosted version. So you can do some of the things that the hosted version of Nuclia does with your own instance of NucliaDB if you use those understanding APIs in your Python program. So yeah, I hope this video has given you a better understanding of vector databases and Nuclia. I'm personally very excited about vector databases and where this technology is going. If you are interested in learning more about vector databases, check out this video from Fireship, who actually released a video while I was in the process of working on this one. It's a pretty good short summary of what vector databases are. If you're interested in natural language processing and you want to integrate large language models into your applications, check out this video I made right in front of my face. It goes over how to integrate some free and open source language models that are actually really powerful into your application using only a few lines of Python code. So check that out if that's something you're interested in. Thanks for watching, and we'll see you in the next one.